I will share my experience at CSWRI Avikanagar. We have investigated pneumonia. One study we conducted, and we collected pneumonic lungs from sheep 79 and goats 8 pneumonic lungs. And these samples were processed for histopathology, then cultural examination, then identification of etiology, and for other purpose. This is initial stage of pneumonia. Here exudate is there, but it is reddish type, predominated by congestion. So this is initial stage of pneumonia. And if you see here, this is red hepatization, and the exudate may be dominated by blood. These are soft consolidation. But in next stage, severe stages, these are hard. Lungs lobes are very hard, and you will feel like liver. So it is gray hepatization. Then also we have seen some suppurative pneumonia with microabscesses. And in some cases, there is severe pneumonia with abscess. Then there is froth inside the lungs. On histopathology, we have classified this pneumonia into acute fibrinous bronchopneumonia, suppurative chronic bronchopneumonia, acute interstitial pneumonia, acute pulmonary congestion, and aspiration pneumonia. On pathology, we find that in acute fibrinous pneumonia, a lot of aggregates of oat cells. Here also you can find, these are all oat cells. This is the characteristic features of Pasteurella pneumonia. Along with that, fibrinous bronchopneumonia and interstitial pneumonia also there. In some cases, particularly in lambs, we find aspiration pneumonia. In some cases, there are suppurative pneumonia. These are suppurative foci. On histopathology, we identified bipolar organisms in the lung tissues by special staining, bipolar staining. Then we performed PCR amplification by using KMT1 gene and confirmed Pasteurella multocida. We conducted PCR for further characterization and typing of this Pasteurella multocida using various genes. And we found that out of 8 isolates of Pasteurella multocida, 6 were of capsular type A and 2 were of capsular type D. B was absent. Then this capsular type A Pasteurella multocida characterized by another genes for further classifications. Then we got Mannheimia hemolytica, 9 isolates, and these are confirmed by specific PCR and by PHSSA gene as serotype 1 specific Mannheimia hemolytica, and also characterized by RP21 and RP22 gene. We also identified isolated more than 46 E. coli isolates, and these E. coli isolates identified whether these E. coli are pathogenic or non-pathogenic. That we identified by PCR examination and also by sequencing of these isolates. In this study, we find that Mannheimia hemolytica, it is around 10.3%. Then Pasteurella multocida, it is around 8%. Then Biberstreinia trialosi. This is important pathogen. Previously, it is known as Pasteurella trialosi. It is just like Pasteurella only, but now it is known as Biberstreinia trialosi, and we are ignoring this infection. We are only concentrating on Mannheimia hemolytica and Pasteurella multocida. Then we isolated 47 E. coli. Apart from this, around 88 isolates were isolated from various bacterial species. Other isolates were Enterococcus species, Streptococcus, Staphylococcus, Pseudomonas aeruginosa, Corynebacterium, Cocuria species, Micrococcus species, Macrococcus species, Moraxilla, then Truperella, Pyogenes, and Acinetobacter. Among these, it is known that Streptococcus, Staphylococcus, Pseudomonas, Corynebacterium are well-known causative agent of pneumonia. These are secondary bacterial infections, but we don't know about these other pathogens, what role they are playing in causing pneumonia. But recently there are many reports that Acinetobacter species are becoming very pathogenic and drug resistant. Also, this Cocuria species upcoming infection. Then we conducted antimicrobial susceptibility testing for Hemolytica and Pasteurella multocida on pre-HEL-OC also. So we found that there is around 55% drug resistance like amoxicillin, ciprofloxacin, enrofloxacin, norfloxacin, and ofloxacin. These are commonly used antibiotics, and we are getting drug resistance for these antibiotics. So while using the antibiotics, you will be cautious, and if you have facility of AST, antimicrobial susceptibility testing facility is there, then you can use that facility, and after identification of sensitive antibiotic, you should use that antibiotic so that you will get result fast and you can control the infection. Then for gram-positive bacteria, we'll find that for cefizim, 68.2% resistance, and for amoxicillin and penicillin, it is around 3 to 7%. And we isolated the RNA and tested samples for parainfluenza 3 virus infection by targeting the fusion protein and matrix protein. But we found that all samples were negative for PI3 infection.